Okay, 8.6. Students will be able to verify and use properties of trapezoids. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. There's a symbol for parallel. And if the legs of a trapezoid are congruent, then it is called an isosceles trapezoid. And we've talked about these before, but now we're going to learn a lot about them today. So, trapezoid base. These are the parallel sides. Okay, so that would be this top here and this bottom here. Those are the bases, and they're parallel. And the base angles are either this set of base angles that goes with the base 2 or this set of base angles that goes with base 1. But basically they are formed by a leg and a base. And these, by the way, are the legs. These are the legs, the things that are not parallel. Okay, got some basic terms down. Let's talk about a theorem here. It says both pair of base angles of an isosceles trapezoid are congruent. And that's really because, we talked about this in class, but that's really because, hey, if I had an isosceles trapezoid, the base angles would be congruent. And an isosceles triangle. And if I cut off the top, well, that's just what an isosceles trapezoid is. It's just an isosceles triangle with the top cut off. And so the base angles are still congruent, and these angles up here are going to be congruent too. Alright, and the other little extra piece of information that you're going to need to know is that since the bases of a trapezoid are parallel, that means the two angles that share a side are same side interior angles of parallel lines, which means they are supplementary. And that means they add up to 180, so hopefully you remember that. So we could say that angle R plus angle Q equals 180, and we could also say that angle S plus angle T equals 180. Alright, there's the basic notes. Now let's put this into practice. I think you should be able to do this one on your own, so if you want to pause it right now, I'll fill it in, and then you could check and see if you did it right. So you may want to pause the video now. Okay. Well, we just said that same side interior angles of parallel lines is supplementary. So if this is 102, that means this has to be 78. And we also said that base angles are congruent. So this is a pair of base angles, and these are a pair of base angles. So this is 102, and this is 78. There we go. We found all the missing angles. Go to the next. Alright. For some reason, my notes left this little line out there. And this statement is that the diagonals of an isosceles trapezoid are congruent. So we could say that BD is congruent with AC. Alright, so diagonals are going to be congruent. In fact, if you wanted to add that to your quadrilateral tree for isosceles trapezoids, you could do that. You could say, hey, diagonals of an isosceles trapezoid are congruent. Let's go to the next one. The segment that joins the midpoints of the legs of a trapezoid are called the median. And this is actually a typo. It should say the segment that joins the midpoints of the legs of a trapezoid is called the median. So that makes a little bit better sense there. So median, that's this guy right here. See this thing here, EF? That is a median. And it's connecting the midpoints of this leg and the midpoint of that leg. Now this is what's important about the median. The median of a trapezoid is always parallel to its bases, and its measure is exactly 1/2 the sum of the measure of the bases. Let me explain what that means. That means if you were to take this space, the top and the bottom, add them together, EF will be exactly half of these two things added together. And so we get this equation, EF equals half of the top and the bottom. Or we could write also that 2 times EF equals DC plus AB. And that's actually usually how I do it. I just like to double the middle and set it equal to the top and the bottom added together. I think it's a little bit simpler. So we did this in class quite a bit, but I'm going to go off to the side and show you some examples. Let's say that you have, a trapezoid, and let's say that this is 5 and this is 10. Well, that means that this median here in the middle has to be exactly in the middle of these two numbers. So you could add these together, 5 and 10 is 15, and divide it by 2 and you would get 7.5. Or you could say, hey, how far away is 5 from 10? It's 5, so that means 7.5 has to be right in the middle. So 2.5 away and 2.5 away. That makes sense. Let's try some different numbers. Let's try a different one here. Let's say I have another trapezoid. And now let's say that this is 8 and this is, 16. So the shortcut here is, we could just say, well, how far is 8 from 16? Well, it's 8 away, right? That means that these two numbers have to be 4 away and 4 away. Well, what's 4 away from 8 and 4 away from 16? Well, 12. So that's kind of the shortcut. That's how I do this in my head if you want a little bit quicker way of doing some of these problems. So let's try a different one now. Let's say I have another trapezoid. And now let's say that I give you the top as 10, and I tell you that this one is, 14. Can you find the bottom one? Well, we would say, well, 10 is 4 away from 14, so I'd go another 4. It'd be 18. You can use this formula that I gave you over here as well, but I think it's a little bit quicker to just kind of see that you're just really taking an average at the top and the bottom. And you can use that. You can use that these are 4 away and these are 4 away, and so there's lots of ways to kind of solve this out. Alright. So with all that, let's take a look at this problem, because this is more like what we're going to see, where they give us some variable expression for each of these segments. Well, I said earlier that this middle thing, if we just double it, we could set it equal to the top plus the bottom. So that's what I'm going to do. Let's zoom in here quite a bit. Let's take the middle, which is 5x minus 8, and times it by 2. And then let's set it equal to the top plus the bottom. Alright, well, I'd get 10x minus 16 equals 6x plus 4. Subtract 6x, subtract 6x. Add 16, add 16. We get, these guys cancel, we get 4x equals 20, so x equals 5. And if we wanted to, we could plug that back in. 2 times 5 is 10, plus 5 is 15. 5 times 5 is 25, minus 8 is 17, which tells me right away, I'm thinking this is going to be 19 down here, because 15 and 17 is 2 away, so I think this is going to be 19. Let's check. 4 times 5 is 10, minus 1. Yep, 19. There we go. Okay, we're almost done with these notes. Here we go. This is the last thing. The diagonals of a kite are always perpendicular. And that's a little symbol right there for perpendicular. And what perpendicular means, in case you forgot, is that it makes a right angle. A right angle. So 90 degrees. So if we wanted to find all the angles here, you guys could probably do this on your own, and you may want to just pause the video. You're going to need to fill in that S though. But if you want to pause the video, I'm going to put the answers up in just a second. So go ahead and do that if you want. Okay. So in order to find all these angles, we know first of all that angle 2 here has to be 90 degrees because it's in the center. And we know that all 4 of these angles are 90 degrees because the diagonals of a kite are perpendicular. That's the rule that we just learned. So these are all 90. Alright, with that being said, we have a little triangle here. We have a right triangle here. And we already know that these two sides have to be congruent with each other. And we know these two sides are both right angles. And we know, hey look, the hypotenuses are congruent. Well, that's enough to prove that these two triangles on the top and bottom are congruent by HL, which tells me that all of the corresponding parts are congruent. So angle 1 is the same thing as 72, so we know that one now. That is 72 degrees. And if this angle is 72 and this angle is 90, I should be able to find this angle pretty easily by just saying, let's call it an x. X plus 72 plus 90 should all add up to 180 because it's a little triangle. 90 and 72 is 162. Subtract that from both sides and you get x equals 18, which is correct. This should be 18 degrees. And there you go. That's how you solve for all the parts of the kite there. Alright, that's it for the 8.6 notes. I'll see you in the next video.